excuse me. We're going to do law of sines. We're going to do two quick examples. So we'll start right here, get right into it. First things first, rest in peace, Uncle Phil. But when I label these angles, just like I did in law of cosines, it doesn't matter how I label them. In fact, I'm not going to label them for this. Just because I want to show you almost not with the formula, even though we're still going to use the formula, still going to use all of that stuff, I'm going to look at it a little bit differently. So first thing we always need to look at for law of sines, and really any triangle, if I'm solving stuff, there's one quick, easy thing I always kind of look for. It just kind of clicks in my head real quick. Is I am given two angles. If I'm given two angles, I'm guaranteed to have a third angle. I know what the third angle is because I know all three angles of a triangle add up to 180. So what I'm going to do is I'm going to take 180, I'm going to subtract 112, and then I'm going to subtract 40. Now I'm not doing 180 minus 112 and 180 minus 40. I'm doing 180 minus 112 minus 40. I'm doing all at once, right? So I'm not doing it individually here. I'm all at once. And that gives me 28. And that tells me that this angle right here is 28 degrees. Cool. Oh, I guess you can't really tell that's an 8, but I'm going to speak it into existence at 28. So I was able to calculate what my third angle is, and that's something I do all the time. If I see two angles of a triangle, I'm going to go ahead in my brain, if it's easy, or calculator if I can't do it in my head, is I'm going to just jot down what that third angle is. Even if I don't need to know it, just because I don't know if I need to know it or not. I just know that if I have two angles, I am guaranteed to have a third. So back to actual law of sines. First, don't say sin. Okay, I'm going to go mini rant here. Don't say sin. There's no sin in math. Math is maybe not awesome, but it's good. There's a lot of good things that come from it. I know you don't want to take this class. I get it. Just don't say sin. Law of sines. Sines. Don't say sin. It hurts. So what we look for in law of sines is I am looking for a pair. So I'm looking for an angle and an opposite side. Now let's be clear about what opposite sides means. Well, first, 112 and 40 cannot be opposite because they are angles. An angle cannot be opposite another angle in a triangle. In a triangle, sides are opposite angles, angles are opposite sides. So this 28-degree angle is created by two sides coming together. So two sides are coming together, that forms my angle. Well, what two sides are being used? This one and this one. So these two sides are being used to form my 28-degree angle. The one that's not included, the one that is not building this angle, is my opposite side. So that's one way to look at it. It's a side that's actually not touching the angle. This side is not touching 28 in any way. It's not there at all. Both of these sides are. All right. Another way to look at it is I think it's like a flashlight. If this is my flashlight, these are my beams of light. My light is shining on this wall. So that's another way to talk about opposites. So those are just two quick explanations, opposites there. So what I'm looking for, and I'm going to go ahead, I'm going to try to solve markers for A and then for B. All right. And I'm only doing A and B only because I have two different colors. I want to show you two different ways. All right. So the first thing I'm going to do is I'm going to solve for A. Is I'm going to write the pair that I have. I have angle and a side here. Because I'm solving for a side, the sides go on top. So this is 14 over sine of 28. 14 over sine of 28. 14, sine of 28. The reason why 14 is on top is because I'm solving for a side. If I wanted to solve for an angle, I could put the angle on top. Now, I want to solve for A. So A is here. And then underneath needs to have a sign of its opposite angle. What angle is opposite A? 112. Right? So this side A it touches the angle 40 and it touches the angle 28. It doesn't touch the angle 112. That means it's opposite. So this is sine of 112. Now, how do I solve this? I'm going to give you a shortcut. If you ever want to know where this came from, you can't see where it comes from, just send me a text or an email, and I'll explain it to you real quick. It takes 4 seconds. All right, but I'm just going to tell you a shortcut. You have what you want to solve for on top, right? So you have what you want to solve for on top. So I'm going to take what's underneath what I want to solve for, and I'm going to put it right there. Oop, lost my screen again. There we go. All right, so I'm going to take that. So what we have here, A is going to equal 14 times, check it out, sine of 112, right? The sine of 112 divided by sine of 28. All right, and then you just plug this into a calculator. So just plug into Desmos when you're calculating. The only thing is on Desmos especially, most calculators default to degrees, but Desmos does not. If you're on Desmos, on the top right, there's a wrench, there's a plus and a minus sign, and above the plus and a minus sign for Zoom is a wrench. Click that wrench. At the very bottom, it'll say radians. You want to click degrees right next to it. So make sure you're in degrees or you're going to get the wrong answer. So I set this up, opposite pair. I was solving for A, so A went on top, and the sine of 112 went there. All I do is, because what I'm solving for is on top is in the numerator, I'm taking this denominator, I'm going to put it on top with the other numerator, and that's a multiplication problem. Then this has to plug into the calculator. All right, if I'm going to solve for B here, I still have to start with my given pair. I need a pair to start. All right, so I have 14 over sine 20, oh goodness, 28 is equal to B, right? B is what I'm solving for, over the sine of, what's the opposite angle? 40. And this one, I guess, kind of goofy, but again, this is the only side that doesn't touch 40. Sine of 40. All right, and then same thing here is what I'm solving for is on top, so I'm going to do my shortcut here. So nothing really changed except for I moved that denominator from here to put on the numerator on the other one. Make sure it's a multiplication and I'm good. And then this isn't my final answer, but I do plug this into Desmos or any calculator and get my answer. Make sure you're following, make sure it looks like this. If it looks differently, you're going to get a different answer. All right, going to this other example. I'm going to do this one quicker. All right, so the first thing I got to do is I need to find my third side length, right? So I'm going to do 180. I'm going to go ahead and subtract 45, subtract 15. I get 120. So the 120 goes there. And I have my pair. I now have an angle and an opposite side. I have a pair. All right, so I'm going to solve for A first. So it's going to be 200 over sine of 120 equals, well, I'm solving for A. So A is right there. What's the opposite angle? 45. Then same thing I did on the other one. What I want to solve is on the numerator. So I'm going to take this denominator. So A equals 200 times sine of 45. Where did that sine of 45 come from? It's my denominator. So this, again, this is a shortcut. And you want to know where it comes from? Just ask me. It's real quick. All right, sine of 45. We're good. I'm going to do B real quick. So again, I got to start with the pair that I'm given. I'm now equal to B over the sine of the opposite angle. That's 15. Identify my denominator underneath what I'm solving for. I want to solve for B. So I get B equals 200 sine of 15, right? That came from the denominator over sine of 120. These are just calculator plugs. So these are real quick examples. If you need more, ask me a question. This is just supposed to be a starting point.